Welcome to video number 3. We're going to start talking about solving equations now, which is a big algebra concept. Hopefully you had some teachers last year that showed you a little bit about this, so not all of this is new. The first thing I'm going to show you is a model using algebra tiles, and the only reason I'm going to show you this is because pictures of algebra tiles are going to show up on assessments, and I don't want you to walk into an assessment never having seen them or being like, what the heck is this? And so I want you to at least see the model and what it looks like and what it means. And so we're going to do one example. It would help if you drew the original model so that you know what this looks like modeled with the algebra tiles. I used them as white and gray because when you do this on when you see this on a worksheet or a test, it's a black and white kind of thing, and so they are white and gray. So I tried to just simulate the colors that you're going to be seeing when you do this later. But I want you to be able to see it. You do not have to do algebra tiles or draw algebra tiles every time you solve an equation, but I do want you to see it. The white ones are your positives, and the gray ones are going to be your negatives. And so these are your units, your ones, and the long rectangles are going to be your x's. So if I'm going to model this equation, the negative 4 plus 7x equals 3, the first thing I'm going to do is I'm going to have to put in 4 negatives. And so I'm going to enter 4 negatives in to represent my negative 4. Then I have got to have my plus 7x. So I need 7 of these x's, and that's quite a few. But I'm going to have 7 x's. And that models the left-hand side of my equation. Now the right-hand side of my equation, I'm going to model with a 3. Well, it's the positive 3, so I'm going to put in 3 positives over here. So this is what this equation looks like modeled with algebra tiles. Just so you know, that's what it's going to look like. And so my algebra, over here where it says algebraic, is going to be just the equation, negative 4 plus 7x equals 3. That's the very first thing I did. Now if I want to solve this, and I'm going to solve it using algebra tiles, and this will be the last time I do this, at least for this kind of problem, because I have negatives on the left and positives on the right, I have got to use zero pairs. So I have to make these negatives cancel out in order to make them go away, because I want these x's alone. In order to make a zero pair, I've got to have 1 positive and 1 negative. Since I have 4 negatives here, I'm going to add in 4 positives to make those cancel out. So these make 0 pairs because 1 positive and 1 negative, they cancel each other out. But if I add 4 positives over here, I have to also add 4 positives over here. And these canceled each other out, so they just disappear. And so algebraically, what I just did was I added 4 to each side. That's what I did. So in the algebraic, I'm going to show that by going plus 4, and so I made a 0 pair right here, and they cancel each other out. So I have 7x equals 7. Well, now to show division with algebra tiles, you don't really. I'm just going to break this up into equal groups. I have 7 x's, and so I need to have equal groups. So I have 7 x's and I have 7 ones, which means that each x equals 1. And so basically what I did was divided this into equal groups, which is just a division problem. And so I have divided both sides by 7 to get that x equals 1, because each x equals 1. That's what that looks like with algebra tiles. You don't have to draw them ever again. You don't have to show this on your paper. If you want to, you can. I have algebra tiles available. You can use them while you're in class. It's all good, but I just need you to see it so that it doesn't mess you up later. Let's practice with some word problems. Number 3, the area of a small triangle is 25 square inches. Well, I've got a problem that involves a triangle, so the first thing I'm going to do is draw myself a triangle. And I know that the area is 25 square inches. This, and what they mean by this is the 25 square inches, is 4 square inches more than a fifth of a larger triangle's area. So I have a bigger triangle and I want to find the area of it. So I have a larger triangle and I want to know what it is. So the 25 square inches is 4 square inches more than a fifth of the larger triangle's area. Well, I don't know the larger triangle's area. So x is going to be the larger triangle's area, and a fifth of that. Taking a fifth of something, I can either do 1/5 times that, or I can do that divided by 5. Means the same thing. So that area divided by 5 means 1/5 of x. That's one way to write it. I think that's simpler than using the fraction, so that's what I'm going to use. If you prefer to put 1/5 x, use 1/5 x. Now I'm going to solve this. Anytime I run across a problem like this and I have a fraction or a division problem going on, I've got something in a denominator, the very first thing I'm going to do is clear my fraction. That way I have nothing but whole numbers to deal with, and it makes my life easier. In order to clear a fraction, I have to multiply the entire equation by the denominator. In this case, the denominator is 5. What that does is cancel out this 5. And then I just have to multiply everything else times 5. Well, 25 times 5 is 125. 4 times 5 is 20. And that just stays x because those 5's cancel each other, leaving me with just the x. Now I can solve this, and it's pretty easy to solve from here. I want x by itself, so I have to get rid of the 20 by doing the opposite of what's already being done. Well, that 20 is a positive 20, so the opposite of that is a negative 20. And if I do minus 20 here, I'm going to do minus 20 here. And so 125 minus 20 is 105 equals x. That tells me that the area of this triangle is 105 inches squared. So there's the answer to number 3. I set up an equation, and then I solved that equation based on the properties that I know. So number 4 is an average question. Ashlyn's scores on her last 4 algebra tests were 82, 86, 91, and 96. We want to know what Ashlyn needs to make on her 5th test if she needs to make a 90 average. We don't know her 5th test. So we're going to say that x equals test number 5. So x is going to represent her 5th test. To find an average, you should know that you take everything, add it up, and divide by how many there are. So she has an 82, an 86, a 91, a 96, and test number 5 that we don't know. Divided by 5, she wants that to come out to equal a 90. That's her goal. She wants an A. So, step 1 is I'm going to add all this stuff together. So I'm going to grab my handy dandy calculator, and I'm going to add this 82 plus 86 plus 91 plus 96 plus 96, which equals 355. So, now I have 355 plus x divided by 5 equals 90. Just like the problem before, I'm going to clear my fraction by multiplying everything by the denominator. So I'm going to multiply by 5, which makes those cancel. But I also have to do this times 5. So I have 355 plus x equals 450. And I want to get x alone. Well, that 355 is positive. The opposite of that is a negative 355. So I have to do negative or minus 355 over here to get what x equals. Well, 450 minus 355, if you don't know that off the top of your head, you grab your handy dandy calculator. Yours might not be as cool as mine, but and it gives you 95. So you get that the average, the grade she needs to get on her next test is a 95 if she wants to make an A. That's what she has to make. It's possible, especially if Ashlyn studies. But so that's there we are. That's where we're going. So now this is to use the VCR method. I'm not going to force you guys to use the VCR method. It's not necessary in this class. However, what I do need you to do is show your steps. Show your work. If you don't have a method for showing your work that works for you currently, then follow my steps and write it like I write it. I need to see what you were doing. Otherwise, I can't help you fix mistakes if you make them. So let's start with number 5. I want to get this y by itself. And the only way I'm going to do that is to start getting rid of things. You always start by getting rid of what is being added or subtracted, and you do the opposite. Well, I have minus 5.7, so I'm going to add 5.7. makes those cancel. But I have to add 5.7 over here as well. So that gives me 7.2 equals 1.2y. Well, I still need y by itself. This, you should know, means multiply, and the opposite of multiplying by 1.2 is dividing by 1.2. So I'm going to divide by 1.2 on each side. Well, 72 divided by 12, I happen to know is 6. So 7.2 divided by 1.2 is going to be 0.6 equals y. So there is your answer. So use the same steps and try number 6. And I think I have said twice that we will talk about these in class. If I do not bring this up, please remind me that I need to go over that question with you in class tomorrow at the beginning. It seems that I am scatterbrained lately. So try number 6. We will talk about it in class. If I forget, please somebody remind me. Amanda, Aubrey, one of you, let me know I need to go over it. Okay, so now number 7 and number 8, they both involve some sort of division. So they look like they have fractions in them. Just like with the two problems, the word problems we did, I'm going to clear my fraction. It's the first thing I'm going to do. The denominator in the fraction I have here is a 3. So step 1, I'm going to multiply this whole thing by 3 so that those two 3's cancel each other out. I have to multiply everything else in the problem by 3 though, so that I have done, it's all even. What I do to one thing, I have to do to everything. So this now becomes 45 equals a minus 6, because I multiplied everything by 3. I want to get that a by itself. Well, the opposite of subtracting 6 is adding 6. So 51 equals a. That's your answer. That's all there is to that. There's nothing more. Okay? Number 8 works the same way. I would clear out that fraction. Okay? I would take this entire thing and multiply it by 4. That way I get rid of that denominator down there, leaving me with x minus 7 over here and negative 8 over here, because I had to also multiply that by 4. This side, when I multiply by 4, the 4's just cancel, leaving me with the numerator. But over here, I really have to multiply by 4. Well, now you've got to find out what x equals. Do the opposite, which is add 7. And you should get that x equals negative 1. That's how you solve a multi-step equation. Okay, you take the steps. If you got a fraction and it's a pretty easy fraction to clear, I want you to clear the fraction. And you might run across some that aren't quite so easy to clear. Those are going to be problems that you're going to deal with in class, where I'm there to answer questions, and we'll talk about those. But it still might happen. Here are a couple of others. I would like you to, again, try those. We will go over them when you come to class tomorrow. Just write them down, see if you can do them. Again, someone remind me that I need to go over them. Pretty please. Consecutive integer problems, I am going to do this 11 with you and then start number 12 so that you can see how they get set up. Consecutive means one right after the other. So like 1 and 2 are consecutive integers because they're one right after the other. You could start listing a bunch more, but the first thing it says is the sum of two consecutive integers is 47. That means if I add up two numbers, it's going to be 47. Most of you are going to be able to do this problem in your head, just guess and check, and do it really fast. The goal here, though, is to write the equation and solve it. So it says to write let statements. That means you need to tell me what your variables are. Anytime you have a consecutive integer problem, you have integer number 1 and integer number 2. One of the integers will always be represented by x. The other integer is going to be represented by something else, okay? Since these are consecutive integers, 1 and 2, or two numbers right next to each other, if one of them is x, in order to get to the next one, I have to add 1. So the second integer is going to be x plus 1. This is true for any time it says consecutive integers. So now it says the sum of these is going to be 47. That means if I add them up, x plus 1 equals 47. And I'm supposed to find out what the two numbers are. Combine like terms like we did yesterday, and you solve this. I'll let you finish that one. We'll talk about the answer tomorrow.